What is mathematics? Why is mathematics useful? Within Math 1010, we went over 3 different units, the first being Geometry of the Earth and Universe, the second being Personal Finance/Algebra, and the third being Consumer Statistics and Probability. Geometry of the Earth and Universe explains diverse mathematical laws. It allowed for many European influences with the history of perspective drawings and projected geometry. This unit allowed questions to be endless, such as, how many universes do we have, or are the stars infinite? Within the Personal Finance/Algebra section, we learned and saw the abuses of the loan system. We went over many different examples of payday lending. Interest rates and debt are calculated, and it shows that they are different from person to person and from country to country. The periodic payment formula allows us to calculate the future value of each payment. Within the Consumer Statistics and Probability section, data is comprehensible to the average person, reliable. If done correctly, the data can be released to the public. The margin of error is small, most of the time if done correctly, and data on worldwide pandemics, average grocery spendings, and average household incomes after the pandemic are calculated within the section. Our first subject that we are going to be talking about is Geometry of our Earth and Universe. A quote that relates back to Geometry of the Earth and Universe by Anthony Garrett Lissy. I think the universe is pure geometry, basically, a beautiful shape twisting around and dancing over space-time. So the definition of Geometry of the Earth and Universe is, geometry is the measurements of both the Earth and universe from many different perspectives. We use formulas and equations to help us better our knowledge of the Earth and universe. Within this section, we used not a lot of equations, but the ones that are listed below are very important. Within the Eratosthenes equation, it is the circumference of the Earth, and Eratosthenes used local data and applied the congruence of alternate interior angles, assuming light rays were parallel, as well as proportional reasoning that the angle measured out the entire 360 degrees and the distance of the opposite angle to the entire circumference of the Earth. And then he used algebra to solve, which is this equation right here, 7.2 over 360 equals 5,000 stadia over circumference. We also use Escher's equation, which is 360 divided by the number of creatures, which gives us different angles for each creature for different perspectives. There are 3 different Pythagorean theorems, which was very new if you took high school math. So the first one would be the Euclidean Pythagorean theorem, which is the one we are all used to, a squared plus b squared equals c squared. But then there is spherical and hyperbolic. The Euclidean Pythagorean theorem does not hold true within these 2 universes because of how different things are shaped. So Pythagorean theorem in the spherical universe is a squared plus b squared is greater than c squared, and within the hyperbolic universe it is a squared plus b squared is less than c squared. So an important person who impacted Geometry of the Earth and Universe would be M.C. Escher. He is a Dutch graphic artist and he was used a lot within our segment. He left clues to discover the geometry he was representing in a given artistic creation. His work taught the class that each creature is the same size in their own world. Within Escher's work, we have to use the sum of angles, symmetric, shortest distance paths, and parallels. The sum of angles can be found for each point in the triangle. You have to count the number of the creatures around a topic and divide 360 degrees by that. Symmetric shortest distance paths can be found when you cut creatures within his work in half. When finding parallels, we examine how many symmetric paths there are to any given line through a given point. Within the 1960s is where a lot of his work is pulled from. The picture to the right is is an example of Escher's circle limit 4, which is something we first looked at when looking at his work. Personal finance and beyond algebra. There are 10 to the 11th stars in the galaxy that used to be a huge number, but it's only 100 billion. It's less than the national deficit. We used to call them astronomical numbers. Now we should call them economical numbers. This is a quote from Richard Feynman, and this quote shows how the number of the stars in the universe can connect to personal finance, which was pretty cool. Personal finance and beyond algebra. Definition is personal finance is the financial management which an individual performs to budget, save, and spend monetary resource over time, taking into account various financial risk and future life events. Algebraic equations are heavily used within this unit to help calculate these future events or budgets and savings. So there were not a lot of different equations used within this segment, but the ones we did use were used a lot. So our first one would be the loan payment formula. It's loan times rate over 1 minus parenthesis 1 plus rate parenthesis close to the negative n. This helped calculate how much your payment would be depending on your loan size. We also use lump sum formula, percent, periodic payment formula, and we learned how to do monthly rates, which x over 12 is just the basic one because that's a monthly rate, but if you did yearly, annual, those are all different. A person who impacted personal finance and beyond algebra is Benjamin Franklin. He left money and lump sum plans to help the cities that meant a lot to him. Ben Franklin had difficulties obtaining a loan himself in the past, so he wanted to make sure it was easier for others. So his legacy impacted the Industrial Revolution heavily. The process of lending money to apprentices, people who didn't pay the money back, in many court cases overall, he made a massive difference in many lives. This unit taught us that one person with a plan could significantly impact others. A result from studying what he did for his people in the 1890s we learned how to use Excel spreadsheets to our advantage. We learned how to calculate lump sum, interest rates, and the averages of earned rates within several years. His legacy, which was 100 years after his death, began within the 1890s, and this spreadsheet right here is actually an example from our handout of all the different formulas we used to calculate how much money he had left over. Consumer statistics and probability. There are no problems left in statistics except the assessment of probability. A quote from a colleague in Lindley. Consumer statistics and probability. The practice of collecting and analyzing numerical data in large quantities, especially for the purpose of inferring proportions in a whole from those in a representative sample. Probability is the measure of the likelihood that an event will occur in a random experience. Within this segment, we use confidence interval, expected value, the golden mean, equation of the line, and regression. A person who impacted consumer statistics and probability was Leonardo da Vinci. Leonardo da Vinci concluded that a person's height is about equal to their arm span measured fingertip to fingertip. That relationship there is between a person's height and the circumference of their head. We found Leonardo da Vinci's idea of the Vitruvian man and its given proportions interesting, and as such we investigated whether there is a strong relationship between arm span and height. Within class, we had to give our own measurements, and then we had a spreadsheet that Dr. Sarah put together, which showed the correlation between if his findings held true or not. We concluded that this might be clinically useful in the case where patients are unable to stand upright for their height to be measured. His work to the right is the Vitruvian Man, and that was created around the 1490s. Our mathematical breakthrough within each segment. The most crucial breakthrough within the segment of geometry is perspective, and that within different universes, Euclidean, hyperbolic, and spherical, many questions that satisfy the laws of Euclidean geometry do not meet the others. There is an equation related to the density of the universe. This is fulfilled within Euclidean universe, however, it is considered less than in the hyperbolic universe and greater than in the spherical universe. The most crucial breakthrough within the segment of personal finance / algebra is that interest rate and debt is different from each person to person and from country to country across time. Within this unit, we went through many examples of great successes and abuses of the loan system, both locally and globally. The most crucial breakthrough within consumer statistics and probability would be that some equations and some algebra and some visualizations and geometry, sum of squares, Pythagorean theorem, compared to least squares regressions, for instance, plus numerical connections. Probability is a mix of the two previous segments as well as implementing a few new things. Probability and statistics help us predict possible outcomes and understand random testings to get relevant and accurate data. And this is my credits. Thank you very much.